Dear First Secondary, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have 4 lessons, Unit 2, Lesson 4. The lesson is called Related Angle. Okay, in this lesson, inshallah, we are going to use the trigonometrical functions as we studied in the last lesson, and we are going to study what the meaning of the related angles. Let's start the lesson. First, this is an introduction for the meaning of the related angle. Okay, for example, if we have a unit circle like this, and we have angle theta belongs to the first quad, we know that the intersection between this line and the unit circle called x and y. So this line, as we see, is x, and this line is y. Okay, I'm going to write this one x. And this is y. The long one x and the short one is y. Okay. Now if I reverse the angle, okay, here in this position, by looking here, the cosine of the angle equal x and the sine of the angle equal y. Again, cosine of the angle equal x and the sine of the angle equal y. If I reverse the angle to be in the second quad, this angle called related angle to this angle, because we have here two congruent triangles, because this here the hypotenuse is the same, and we have the same theta, and we have right angle, so those two triangles are congruent. So they called congruent triangle, and theta here and here are equal, so they are related angles. Okay, here the position, by looking to this one, this is x. So I will call this one negative x, y, because this one has the same length of x but in the negative direction. And this is positive y, because this is in the positive direction of y. So the coordinates here of this point is negative x and y, like this. So if the angle in the first quad and it is changed to be in the second quad, we have a change in the coordinates. X and y becomes negative x and positive y. Okay, now this angle is called 180 minus theta. How come? Okay, now the angle in the standard position comes from the positive direction of x-axis to this line. Okay, now I can't measure this one, but I can measure this one by another way. Straight angle equal 180 minus theta gives me the angle. Okay, now the angle 180 minus theta, its cosine equal negative x and its sine equal positive y. Okay, so its cosine 180 minus theta equal cosine theta, negative cosine theta, because this is negative x, and sine 180 minus theta equal sine theta, because they have the same coordinate. Again, cosine 180 minus theta equal negative cosine theta, and sine 180 minus theta equal sine theta. And I'm going to explain later how can we conclude these rules. This is just introduction example to teach you what the meaning of related angles. Okay. Now, if we have another position for the triangle, like this, I make a rotate the triangle. Now we have a related angle to angle theta, but related to y-axis. Okay, now by looking here, this is x, and this is also x. This is y, and this is also y, but this is negative y. So why negative y? Because this is in the negative direction of x-axis. Okay, here the length, this coordinate is x coordinate, and its length equal negative the length of y, and this coordinate is y coordinate, but its length equal the coordinate of x, so it will be negative y and x. Okay, now to have this angle is equal, this is 90 degrees plus theta. So this angle equal 90 plus theta. Okay, to find cosine 90 plus theta. Cosine 90 plus theta equal negative y equal negative sine theta. Why? Because y is sine theta. Okay, so cosine 90 plus theta equal negative sine theta. Okay, now sine 180 plus theta equal x, and x is cosine theta. Okay, so I make 180 minus theta in terms of cosine and sine theta, and 90 plus theta in terms of negative sine theta and cosine theta. Okay, now I'm going to change the triangle in another position like this. This angle is here 180 plus theta. Okay, this is x and this is negative x. This is y and this is negative y. The coordinates of this point is negative x and negative y. Okay, now 180 plus theta. This is 180 plus theta. Its cosine equal negative cosine x, equal negative x, equal negative cosine theta. And its sine equal negative sine theta. So cosine 180 plus theta equal negative cosine theta, and the sine 180 plus theta equal negative sine theta. This is just an introduction for the meaning of related angles. The related angles means angles in different quads. The same angle but in different quad. Okay, now let's study how can we identify the rule of the related angle. Okay. First, I'm going to divide the related angle into two parts. Angles related to x-axis and angles related to y-axis. I'm going to start with angles related to x-axis. Okay. Now, by using the unit circle. Here, angle theta, its coordinate x and y. And the angle here, here's the angle with x-axis. Another angle here, angle also with x-axis but in different direction. Okay, this one is negative y and x. Another angle with x-axis here, this one, its coordinate negative x and negative y. Another angle with x-axis here in the fourth quad. Okay, now we have four angles in the fourth quad. Theta, and this one 180 minus theta, 180 plus theta, 360 minus theta. Okay, by looking carefully to the four coordinates xy, negative xy, negative x, negative y, x, negative y. Here we have x and y lie in the same position. xy, 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 xy. The first one is x forever and the second one is y forever. Okay, the change in the sign only. Here there is a change in x, and here there is a change in x and y, and here there is a change in y only. So the related angles to x-axis, the change will be in the change will be in the sign only. So okay, now I'm going to call the angles theta, 180 minus theta, 180 plus theta, 360 minus theta. Okay, now as I said before, the change will be in the sign only. I do what to make the rule to conclude the rule of each one. Okay, first, step number one, put the sign according to the quadrant. What does it mean? I'm going to put the sign of the new angle or the new function according to the quad. We studied before the asterisk rule. Okay, the asterisk rule here, all all are positive. Here the sine is positive, here the tan only is positive, here the cosine is positive. Okay, then step number 1, put the sign according to the quadrant. Step number 2, keep the function. Keep the function because the ordered pairs don't change in any of the quads. For example, if we have angle 180 minus theta, step 1, put the sign according to the quadrant. Okay, sine 180 minus theta. 180 minus theta here in the second quad. Okay, look to the sign. The sign here will be changed or will be the same. The sign in the second quad is positive, so the answer here is positive. Okay, step number 2, keep the function, so it will be sine theta. Another example, if we have sine 180 plus theta, 180 plus theta is in the third quad. So, by looking to the third quad, sine in the third quad will be changed because the 10 only is positive. Okay, so it will be negative. And keep the function, so I will write down sine with negative to be negative sine theta. Another example, if we have tan 180 plus theta, 180 plus theta lie in the third quadrant, so I will, okay, tan in the third quadrant is positive, so the answer of this one is positive. And keep the function, so it will be tan theta in each one, and I ignore the number and write down sine theta, tan theta, but by using the sign according to the asterisk rule. Okay, cosine 360 minus theta, 360 minus theta. Okay, here this is the fourth quad and this is cosine. The cosine in the fourth quad is positive, so the answer here is positive. And ignore and keep the function without change, it will be cosine theta. And if we have cosine 180 minus theta, cosine 180 minus theta in the second quad, in the second quad cosine is negative, so it will be negative cosine theta. Okay, tan 180 minus theta, this is the second quad. Okay, second quad, tan is negative, so it will be negative tan theta. In all of them, notice that I make the function without change. Sine, 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 tan, tan, cosine, 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 tan, tan. The same rules lie using with the sec, cosec, and cotan. Okay, now let's study the negative angles. Okay, the negative angles. First, if we have angle theta like this. Okay, the angle related to the direction of the rotation. Okay, the rotation here comes from here to here, so it is a positive direction. Now, another angle, its coordinate x and y, another angle comes from here to here, so its direction is negative. So, this is theta and this is negative theta. The coordinates of negative theta will be x and negative y. Again, the coordinates here x and y, the coordinates here x and negative y. Okay, so x, okay, theta and the negative theta, x is the same but y change. So cosine theta exact as cosine negative theta. Again, cosine theta and cosine negative theta are equal, but sine theta and sine negative theta have opposite sign. So it will be like this: sine negative theta equal negative sine theta. Okay, and cosec negative, cosec is 1 over have the same rule of the sine, so it will be negative cosec theta. And tan theta, tan equal y over x, and here tan equal negative y over x. So tan negative theta equal negative y over x. Okay, here equal negative tan theta. And cotan have the same rule of tan. Cotan negative theta equal negative cotan theta. Okay, cosine negative theta here is x and cosine theta is x. So cosine negative theta equal cosine theta, and sec negative theta equal sec theta. So cosine ignore cosine negative theta, we cancel the sign to be cosine theta or sec theta. But if we have sine or tan or its multiplicative inverse, we change the sign outside, the negative outside the function. Okay, this is the negative, the functions of the negative angle. Okay, let's study the next question. Find the value of each of the following. Number 1, cosine 120, tan 225, and so on. Okay, now step 1, make all angles less than 360. Okay, this is less than 360, this is less than, but this is minus 360 equal 60. This is the first step. Second step, make the sign, check the quadrant of each angle. This angle in the second quadrant. This angle in the third quadrant. This angle in the fourth quadrant. And this is first quadrant. Remember with me the Aztec rule. Okay, now change 120 to be 100 in the second quadrant. Remember with me. In the first quadrant, theta. In the second, 180 minus theta. And 180 plus theta. And 360 minus theta. Again, theta, 180 minus theta, 180 plus theta, 360 minus theta. Okay, because this one belongs to the second quadrant, so I will make 120, 180 minus number, it will be 180 minus 60. So the first angle, cosine 180 minus 60. Here, the second angle, tan 225, 180 plus number. I will change this one, 180 plus one plus number. 225 equals 180 plus 45. Plus cosec 330, I will make it 360 minus number. This is 360 minus 30. And this is cosine 60 without change, because theta in the first written without change. Cosine 60. Okay. Now, here, cosine in the second quadrant. Okay, we write it cosine 60. But cosine in the second quadrant is negative, so it will be negative. Cosine 60. Plus tan 180 plus 45, it will be tan 45. Okay, this is the third quad, and the tan in the third quad is positive, so it will be without change. Plus cosec 30. Okay, 30, this is the fourth quad. Cosec in the fourth quad, cosec is the opposite of sine, and sine is negative, so it will be negative. Plus cosine 60. Okay, negative cosine 60 equals negative half. plus tan 45 equals 1 plus negative 2 cosec 30, which is 1 over sine 30. Okay, plus cosine 60, which is half. Finally, this one equal to negative 1. Again, check, make all the numbers less than 360. This is step number 1. Step number 2, check the quadrant of each angle. Step number 3, okay, write the rule of the quadrant as I wrote here. This is the rule of the quadrants. Theta 180 minus theta, 180 plus theta, 360 minus theta. Okay, then change each angle according to this rule. For example, 120 equal 180 minus 60. 225, 180 plus 45. 330 equals 360 minus 30, and so on. So use the rule before the rule. We keep the function. How come? Cosine, cosine, tan, tan, cosec, cosec, cosine, cosine. Okay, and then use the asterisk rule to write the sign of each function. Okay. Number 2, sine 150 cosine negative 300, cosine 900. Okay, number 1, this is less than 360. This is a negative angle. Okay, and so you can you have two options. You can add 360, or you can ignore the negative because this is cosine. Okay, I will add 360. 360 plus negative 300 equal 60. So this angle equal 60. Okay, cosine 930. I will subtract minus 360 minus 360. Okay, it will be 210. Again, minus 360 two times, it will be 210. Okay, 240 at the same as without change. Okay, now I'm going to write the rule of the quadrants. Theta 180 minus theta, 180 plus theta, 360 minus theta. Okay, now sine 150. This is in the second quad. Second quad 180 minus this number, so it will be sine 180 minus 30. Number 2, cosine 60 plus cosine 210. 210 belongs to the third quad, so it will be 180 minus what? It will be 180 minus plus 30. Cosine 180 plus 30. Finally, cotan 240. Cotan 180 plus what? Equals 240 plus 60. Okay. Now, the second step, I will keep the function in all of them sine 30. But this is the second quadrant by looking to the asterisk rule. This is the second quadrant. Sine in the second is positive, so it will be positive. Here, cosine 60 in the first quadrant plus cosine 180. This is the third quad, and cosine in the third quad is negative, so it will be negative cosine 30. Finally, cotan in the third quad is positive, so it will be cotan 60, like this. Okay, now I will write the equal of each one. Half sine 30 equals half, times cosine 60 also half, plus negative cosine 30 root 3 over 2 times cotan 60, which 1 over tan 60 means 1 over root 3. Finally, this one equals negative 1 over 4. Next. Now we have here radian measurements. So number 1 equal 10 2 pi over 3, 2 pi over 3, 2 times 180 over 3 equals 120, sec 11 pi over 3 equals 660, 11 times 180 over 3 equals 660, plus cotan 11 pi over 6 cotan 11 pi over 6 equal cotan 330, 11 times 180 over 6, and cosec 19 pi over 6 equal 570, plus tan 25 pi over 6 equal 750, tan 750, cosec negative 19 pi over 3 equal negative 1140, negative 1140. Okay, this is the first step. The second step, make all angles less than 360. Okay, the first angle less than 120, less than 360, sec 660 minus 360 equal 300s, plus cotan 330, cosec 570 minus 360 equals 210, plus tan 750 minus 360 minus 360 equals 30, and this angle plus 360 plus 360 plus 360 plus 360 equals 360 equals 300. Cosec 300. Again, I will add 364 times to this angle. It give me 300. Okay, now the quadrants. Here in the first quadrant theta, in the second quadrant 180 minus theta, 180 plus theta, 360 minus theta. Okay, back to this. 120 minus 120 in the second quadrant, it will be 180 minus 60. 180 minus 60. Okay, sec 300, which is 360 minus 60. Plus cotan 360, which is 360 minus 30. Cosec 210, which is cosec 210 in the third quad, it will be 180 plus 30 plus the rest of the line tan 30 cosec 300 equal 360 minus 60. Okay, now I'm going to tan 180 minus 60 equal tan 60. This is second quad. Tan in the second quad is negative. Okay, sec 360 minus 60. Okay, sec in the fourth quad is positive. So it will be sec 60 plus cotan 360 minus 30. This is the fourth quad, and cotan in the fourth quad is negative. It will be negative cotan 30 times sec 180 plus 30. This is the third quad, and cosec in the third quad is negative. So it will be negative cosec 30 plus tan 30 times cosec 360 minus 60. Cosec in the fourth quad is negative, so it will be negative cosec 60. Okay, here the answer: negative root negative tan 60 equal negative root 3 sec 60, or 1 over cosine 60 equal to plus 1 over tan 30 equal negative root 3 times cosec 30, 1 over sine 30 equal negative 2 over root 3 plus tan 60 tan 30 equal 1 over root 3 times cosec 60, or 1 over sine 60 equal negative 2 over root 3. Evaluate the whole line equal negative 2 over 3. Okay, now example 2. Prove that each of the following. Start with the left hand side. Here 600 minus 360 equal 240, and cosine cancels the negative, so it will be cosine 30 direct. 150 less than 180, 360, sorry, and negative 240 cosine, ignore the negative. Okay, now sine 240. Sine 240, remember with me the quads. Theta 180 minus theta 180 plus theta 360 minus theta. Okay, and the asterisk rule. Here 240 sine 240 in the third quad equal 180 plus 60. Sine 180 plus 60 cosine 30 plus sine 150 in the second quad, it will be 180 minus 30. Sine 180 minus 30. Cosine 240, it will be cosine 180 plus 60. Okay, now it's equal sine 180 plus 60. In the third quad, sine is negative, so it will be negative sine 60 times cosine 30 plus sine 180 minus 30. Second quad, sine in the second quad is positive, so it will be sine 30 times cosine 180 plus 60, third quad. So cosine in the third quad is negative, so it will be negative cosine 60 equal negative root 3 over 2 times root 3 over 2 plus 1 over 2 times negative 1 over 2 equals negative 1. Therefore, the left hand side equal to the right hand side. Okay, now let's study the related angle in y-axis, and let me show you what will happen when we rotate the angle according to y-axis. Okay, now we have here angle theta. Don't forget that if its coordinate is x and y, so this is x and this is y. The smaller one is x and the greater one is x and the smaller one is y. What will happen when we rotate this triangle according to y-axis like this? So the bigger one, this is x and the smaller one is y. But here this is negative y because this is in the negative direction. Okay, the coordinates of this point will be x coordinate and y coordinate. Here in the x coordinate is negative y and the y coordinate is x. It will be like this. So what happened to the point? We have here two changes, x and y to negative y and x. We have to change. We have a change in the sign and we have a change in the position. X becomes y and y becomes x. So cosine becomes negative sine and the sine becomes cosine. So there is a change in the sign and a change in the function. Okay, what will happen according to the angle here in this position? Here in this position, this is negative x and this is negative y. So the x coordinate is called the negative y, the y coordinate is called the negative x. So the point will be like this, negative y, negative x. Negative sine, negative cosine. Cosine becomes negative sine and sine becomes negative cosine. Okay, there's two changes in the sine and in the function. Okay, here this angle, this is x, it will be negative x, and this one is positive y. Okay, this is the x coordinate. The x coordinate becomes y and this is y coordinate becomes a negative x, so the point will be y and the negative x like this. Okay, x becomes y, cosine becomes sine, and sine becomes a negative cosine. So what I need to do, what I need to say here, if the angle related to y-axis, it's called what? In the first quadrant, the angle is called theta. Okay, in the first quadrant here, the angle is 90 minus theta. In the second quadrant is 90 plus theta. Here 270 minus theta. And here 270 plus theta. 90 and 270. This is 90 degrees and this is 270 degrees. So the two angles 90 and 270 related the angles of y-axis. So here 90 minus theta plus theta, 270 minus theta, 270 plus theta. Okay, to change the function according to 90 and 270, we do what? Step 1, put the sign according to the quadrant or asterisk rule briefly. Step 1, we put the sign negative or positive according to the asterisk rule. Okay, and this is very clear from the previous rules. Okay, number 2, here we have change the function. Change the function. Here we notice x and y, change it to be negative y and x and so on. Okay, change the function. How come? Sine becomes negative, sine becomes cosine, and the cosine becomes sine, and tan becomes cotan, and the cotan becomes tan. Sec becomes cosec, and the cosec becomes sec. This is in order to use 90 and 270 angles. Okay, for example, sine 90 minus theta. First, sine change into cosine, and by looking to 90 minus theta, which is the first quadrant, sine in the first quadrant is positive, so it will be positive cosine theta. Another one, sine 270 plus theta. Sine will be changed to be cosine, and this is the fourth quad. Sine in the fourth quad is negative. Remember, here we are going to look to the first function, not the second function. Okay, so sine will be negative cosine theta. Here we have tan 270 plus theta. Okay, here tan change to be cotan, and 270 plus theta, fourth quadrant, tan in the fourth quadrant is negative, so it will be negative cotan theta. Finally, okay, cosine 270 minus theta, cosine change to be sine, and this is the third quad. Cosine in the third quad is negative, it will be negative sine theta. Finally, cosine 90 plus pi, 90 plus theta, 90 cosine change to be sine, and this is the second quad. Cosine in the second quad is negative, it will be negative sine theta. Then 270 minus theta, here we have tan change to be cotan, and 270 minus theta is the third quadrant, and tan is positive in the third quadrant, so it will be positive cotan theta. Okay, let's solve the next question. If the terminal side of angle theta in the standard position intersects the unit circle at the point negative 3 and 5 over 5 and 4 over 5. Okay, here this is x and this is y. This is cosine theta, this is sine theta. Okay, now he need what? Cosine pi minus pi over 2 minus theta. Okay, pi over 2 means 90 minus theta. Okay, if we have 90 or 270, then we choose cosine into sine theta. This is the first step, and put the sign according to asterisk rule. This is the first quadrant. Cosine is positive in the first quadrant, so we have here sine theta. Sine theta equal 4 over 5. I think it's very easy. Number 2, 3 pi over 2, which is 270 minus theta. Okay, so cosec change to be sec theta. Okay, this is the third quadrant. The third quadrant, cosec in the third quadrant is negative, so it will be negative sec theta. Okay, negative sec theta. Sec is 1 over cosine, so it will be negative 5 over 3. It will be positive 5 over 3. Now sec pi plus theta or 180 plus theta. Don't forget, 180 doesn't change the function, so it will be sec theta without change. But here, okay, 180 plus theta in the third quadrant, and sec in the third quadrant is negative, so it will be negative sec theta. So negative sec is 1 over cosine, so it will be negative 5 over 3. It will be 5 over 3. Next. Here we have cosine theta equal negative 5 over negative 3 over 5, and theta belongs to the third quadrant. Remember with me, the third quadrant is negative. Okay, so sine is negative and the cosine is negative. Okay, now I can solve by two different ways. I can draw this one, or I can use the unit circle. It's up to you. I'm going to use the unit circle here. This is cosine theta, or x equal negative 3 over 5. So y, x power of 2 plus y power of 2 equals 1. So so negative 3 over 5 all power of 2 plus y power of 2 equals 1. I'm sending this one to the other side and take the root. Therefore y equal negative or positive square root 1 minus negative 3 power of 2 9, 5 power of 2 25. It will be 9 over 25. Here y must be negative, so I will take the negative only, so it will be negative root 1 minus 9 over 25 equals 4 over 5. So this is y, or sine theta. Now we have cosine theta equals negative 3 over 5 and sine theta equal negative 4 over 5. Number one, we need cotan theta minus pi. Okay, this is not 90 minus theta. This is theta minus 90. So I will make it cotan negative bracket 90 minus theta. This is the first step. And in the negative angles, okay, cotan still negative. It will make the negative outside like this. So it will be negative cotan 90 minus pi. Okay, now 90 minus pi, cotan changed to be 10. Negative 10 theta. Okay, don't forget the negative comes from here. Okay, and this is the first quadrant, so cotan in the first quadrant is positive, so I will not change this sign. Okay, now it will be what? Equal negative tan theta. Tan equal y over x, or sine over cosine. Negative 4 over 5 divided negative 3 over 5 equal 4 over 3. Equals negative 4 equal 4 over 3. Okay. Number 2. Okay, sec 90 plus theta. This one equal. First I'm going to change sec into cosec theta. And this is the second quad. In the second quad, sec is negative, so it will be negative. I'm locked to this one, not this one. Okay, negative cosec theta, negative cosec theta. Here cosec is 1 over sine, so it will be negative negative 5 over 4 equals positive 5 over 4. Number 3, tan 270 minus theta, tan changed to be cotan theta, and this is the third quad. In the third quad, tan is positive, so it will be cotan without change. Cotan equal 1 over 10, and the tan here, or cotan equal x over y, or cosine over sine. Negative 3 over 5 divided negative 4 over 5 equals 3 over 4. Number 4, sec negative theta. Sec, in the negative sign, sec cancel the negative, sec like cosine, so sec theta equal 1 over cosine theta equal negative 5 over 3. Next. If theta is a measure of the positive acute angle in the standard position and its terminal side intersect the unit circle at the point x and 3 over 5, find the value of. Okay, first I need to find the value of x. Don't forget theta is an acute angle, so this is belong to the first quadrant, so it will be positive positive. This is a very important remark. Okay, now theta, by using the Pythagorean theorem, x equal square root 1 minus 3 over 5 all power of 2. Here we have negative or positive, so it will be equals 4 over 5. Negative 4 over 5 is refused. Okay, this is the first question, the first part of the question. Okay, now remember with me, sine 90 minus pi, change the sign, sine 90 minus theta, it will be cosine theta, and this is the first equation, so it will be still cosine theta, plus tan 90 minus theta, tan changed to be cotan theta, and this is the first quad, so it will be positive cotan theta. Cosine 90 plus theta changed to be sine theta, but this is the second quadrant, cosine is negative, so I will make it negative sine theta. Okay, now cosine theta, which is 4 over 5, plus cotan theta, cotan equal x over y, equal 4 over 5 divided 3 over 5, again 4 over 5 divided 3 over 5 equal 4 over 3, times negative sine theta, or negative 3 over 5. This one equal to 0. Now let's see the equation. How can we solve the equation by using the trigonometrical functions? Also by using the unit circle, here we have by using this right angle triangle. Okay, if we have angle alpha and beta, this symbol called alpha and this one is called beta. Okay, here we have the x coordinate, this is the x coordinate and this is y coordinate. Okay, and the hypotenuse equal 1. Now, by looking first the first information we have that x plus alpha plus beta equals 90 because they are two acute angles in right angle triangle. Okay, now look at me here. Now if I need sine alpha, sine alpha equal opposite over hypotenuse equals y. Okay, cosine beta, cosine beta equal adjacent over hypotenuse equal y. So what? Sine alpha and cosine beta are equal. This is the first rule with us. Cosine alpha and sine beta are equal. Okay. Now, tan alpha equal tan alpha equal y over x. And cotan beta, cotan beta, cotan equal adjacent over hypotenuse, y over x. So, tan alpha equals cotan beta. This is the second relation. Tan alpha equal cotan beta. Okay, the third relation, sec alpha, sec alpha, sec equal is the opposite of cosine, okay, which is the adjacent over hypotenuse. Adjacent over hypotenuse over adjacent, which is 1 over x. Okay, cosec beta, cosec beta equal hypotenuse over opposite, because cosec equal 1 over sine, so it will be 1 over x also. So sec alpha equal cosec beta. Now we can conclude what? If two angles, if sine alpha equal cosine beta, then the sum of them equal 90. And if tan alpha equal cotan beta, then the sum equals 90. And if sec alpha equal cosec beta, then the sum equals 90. This is the rule that we use to solve the equation. Okay, let's solve the first question with us. Example 6. In this example, find one of the values of theta where theta belongs to 0 to 90. Okay, now since theta belongs to 0 to 90, then theta must be acute angle. Okay, here we have sine this bracket equal cosine this bracket. When sine and cosine equal, then the sum equals 90. Therefore, 3 theta plus 15 plus 2 theta minus 5 equals 90. Here we have 3 theta and 2 theta equals 5 theta. 15 minus 5 equal 10 equals 90. I'm going to send 10 as minus to say, then it will be 90 minus 10 equals 80. So 5 theta equals 80. So theta, I'm going to send 5 as a divide. It will be 80 divided by 5 equals 16. So theta equals 16 degrees. Okay. He said find the value of theta. Okay, then there isn't solution set. Okay, number 2. Sec theta plus 25 equal cosec theta plus 15. So the sum of the two angles equals 90. Okay, theta plus theta equals 2 theta. 25 plus 15 equals 40 equals 90. I wrote 140. It's 40. Okay, now by sending 40 to the other side minus, 90 minus 40 equals 50. Then 2 theta equals 50. Divided by 2, then theta equals 25 degrees, and this is an acute angle. Okay. Now, number 3. Tan theta plus 20 equal cotan 3 theta plus 30. When tan and cotan are equal, then the sum equals 90. So, theta plus 3 theta equals 4 theta. 20 plus 30 equals 50 equals 90. Send 50 there as minus, it will be 40. Then 4 theta equals 40. Send 4 as divided, then theta equals 40 divided by 4 equals 10 degrees. Now let's study the general solution of the equation. What the meaning of general solution? We studied before that if we have angle like this angle equal theta. Okay, then if we have another angle in which we make a whole turn and go the same terminal side, then theta equal 360 plus theta. Okay, if we have another turn, then it will be theta plus 360 times 2 and so on. So we have infinite number of terminal sides at the same, equal to the same angle. So I have infinite number of solutions for the same equation, for the same angle. Again, when we solve an equation, so we have infinite number of solutions for the same angle. Okay, when he asked me find the general solution, so I need a solution can used for the all angles. Okay, now let's see the first one. If sine alpha equal cosine beta, we said before that sine equal cosines, then alpha plus beta equals 90. Okay, or alpha minus beta equals 90. So it will be like this: alpha plus beta equals 90 plus 360n. What does it mean? Okay, if I turn the angle 1 or 2 or 3 or 4 and so on, so every turn equals 360. So 360n means the number of turns around the coordinate axis. Okay, this is the first rule: alpha positive or negative beta equal 90 plus 360n, or 90 equal pi over 2 and 360 equal 2 pi. So it will, I can write this one by this way: pi over 2 plus 2 pi n. N here because the number of turns of the around the coordinate axis. Okay, number 2, if cosec alpha equal sec beta, then alpha plus beta equal also 90 plus 360n, sum equal 90. This is the main rule, but 360n because the number of turns around the coordinate axis. Okay, or I can write it as pi over 2 and 2 pi, like this: pi over 2 plus 2n pi. Now tan has a different rule. Okay, tan alpha plus equal cotan beta, again tan alpha equal cotan beta, so alpha plus beta, not alpha plus or minus beta, equal 90 plus 180n. Again, 90 plus 180 80 n, or pi over 2 plus pi n, like this, pi over 2 plus pi n. Okay, note something here. I must start the equation with sine to the left and cosine to the right, or cosec to the left and sec to the right, or tan to the left, cotan to the right. Okay, so if he gives me cosine to the left and sine to the right, I have to change the function. Okay, this is the general solution I'm going to use. Okay, let's solve the next question. Now we have example 7. Find the general solution for each of the following equations. Okay, now he asked me general solution without identify any quads, so I just write the general solution, and it's better to write with the radian measurement, so I will solve it with radian measurement, but you can solve it with the degree measurement. Okay, first I have here sine to the left and cosine to the right. It's okay. Okay, it's okay. Now I have two solutions. The first solution, the sum equal pi over 2 plus 2n pi. The second solution, the difference equal pi over 2 plus n pi. Okay, the sum equal 2 theta plus theta equal 3 theta equal pi over 2 plus 2n pi, or 2 pi n, whatever. Okay, the second solution, the difference 2 theta minus theta equal theta equal pi over 2 plus 2n pi, or 2 pi n. Okay, now I need theta, so I will send 3 there as a divide. Okay, pi over 2 divided by 3. Pi over 2 divided by 3 equal pi over 6. Plus 2 pi over 3 equal 2 pi over 6. 2 pi over 3. 2 pi n over 3. Okay, now this is the first solution. The second solution is this one. So solutions are pi over 6 plus 2 pi n over 3, comma, pi over 2 plus 2 pi n. I think it's very easy. You can solve it by using the numbers, it's okay. By using 90 in place of pi over 2 and 360 in place of 2 pi. Okay, and this is the second solution. Both are correct. Okay, number 2. Cosine 5 theta equals sine theta. So I have to start with sine, so I will make the equation like this. Sine theta equals cosine 5 theta. Now the first solution. The first solution, the sum equal pi over 2 plus 2 pi n. So it will be theta plus 5 theta, 6 theta equals pi over 2 plus 2 pi n. The second solution, the difference equal the same value. The difference is theta minus 5 equal negative 4 theta equals pi over 2 plus 2 pi n. Okay, now I'm going to send 6 as a divide. Pi over 2 divided by 6 equal pi over 12. Theta equals pi over 12 plus 2 pi divided by 6 equal pi over 3. Pi n over 3. You can solve it by using the calculator. I will show you. This is the calculator. Now, if I need pi over 2 divided by 6, it will be like this. Pi over 2 divided by 6 equal 1 over 12 pi, or your calculator gives you pi over 12. Both are correct. And here 2 pi over 6, I will show you also. 2 pi divided 6 or over 6 equal 1 over 3 pi or pi over 3. You can write it as 1 over 3 pi n. Both are correct. Okay, the second one, here divided by negative 4, pi over 2 divided by negative 4 equal negative pi over 8. Theta equal negative pi over 8. 2 pi n divided by negative 4 equal negative pi over 2 n. And those are the solutions. Okay, next one. Here, find all the values of theta where theta belongs to 0 and pi over 2, which satisfy the following equation. 2 cosine theta minus 1 equal 0. First, I'm going to send 1 to the other side, so 2 cosine theta equals 1. So I'm going to send 2 to the other side, so cosine theta equals 1 over 2. Okay, now find, here theta is positive. Theta is positive in the first or the fourth, because this is cosine. But 0, theta here belongs to 0 and pi over 2 belongs to the first only, so this one is refused. So I will take the first only. So theta equal shift cosine half. So theta equal shift cosine half equal 60 degrees. So the solution set, or theta equal 60 degrees. Okay, the next one. Number 2, 2 cosine pi over 2 minus theta equals 1. First, I have to change this form from related angle in terms of theta. Okay, pi over 2, which is 90 minus theta, changed to be 2 sine theta equal 1. This is the first quad, so the cosine is positive, so I will leave it like this. I'm going to send 2 there, so 2 sine theta equals 1 over 2, and sine is positive in the first and second. Okay, second, but second is refused because he asked me about the first only, so I will use theta equal half, shift sine half, so theta equal 30 degrees. Okay. Example 9. Find the solution set of each of the following equations, knowing that theta belongs to theta and 2 pi. Okay, number 1. 2 sine theta equal minus root 3 equals 0. I'm going to send root 3 there. So 2 sine theta equals positive root 3. I'm going to send 2. So sine theta equal root 3 over 2. Okay, here this is a positive sign. The positive in the first and second by using the asterisk rule. Here theta belong from theta from 0 to 2 pi. So I'm going to take all possible values for theta. Okay. In the first quad, remember with me. The first, it was theta. The second, 180 minus theta. The third, 180 plus theta. 360 minus theta. Theta equal what? Theta equal shift sine root 3 over 2 equal 60. This is the first quadrant. Okay, in the second quadrant, it's equal 180 minus theta. 180 minus theta equals 180 minus 60 equals 120. Therefore, solution set equals 60 and 120 degrees. You can check sine 60 equal root 3 over 2 and sine 120 equal root 3 over 2. You can check by using your calculator. Number 2. Now, sine squared theta equals 1 over 4. So I will send square root power 2 as a square root. So sine theta equal negative or positive square root 1 over 4, which is equal 1 over 2. Now we have negative or positive for sine theta. Sine is positive at the first and the third, and it is negative in the second, in the third and the fourth. So I will solve it in the first, in the second, third and fourth quadrants. Okay, in the first it is equal theta. In the second, 180 minus theta. In the third, 180 plus theta. In the fourth, it's 360 minus theta. Theta equal shift sine half. Again, shift sine half equal 30. And here, 180 minus 30 equals 150. And here, 180 plus 30 equal 210. And here, 360 minus 30 equals 330 degrees. So, the solution set equals 30, 150, 210, and 330 degrees. Okay. Now we have here in this example cosine 3 pi over 2 minus theta equal root 3 over 2 and sine pi over 2 plus theta equal half. Find the measure of the smallest positive angle of theta. Okay, first cosine 3 pi minus 2 or 270 minus theta equal 270 minus theta. 270 change the function, so it will be sine theta equal root 3 over 2. But in the third quad, cosine is negative, so it will be negative sine. So sine theta equal negative root 3 over 2. Now sign is negative. Sign is negative in the third or the fourth quadrant. Okay, it will be third or fourth because it's negative. In the third, the angle equal 180 plus theta, and here 360 minus theta. So shift sine root 3 over 2 equal 60. Shift sine root 3 over 2, sine 60 equal root 3 over 2. Excellent. So it will be 240. 180 plus 60 equal 240, and 360 minus 60 equal 300. Okay, now I have two solutions. I'm going to check the other equation to choose which solution I'm going to use. Okay, now in the other case, I have sine pi over 2 theta equal half. Pi over 2, which is 90, so it will be cosine theta equal half. And this is the second quad. Sign in the second quad is positive, so it will be like this. Now shift cosine. Cosine is positive in the first or in the fourth quad. Okay, now it's clear this is the solution. Why? Because there isn't the first here and here. So I will check only in the fourth quad. The fourth quad, it called here, the first quad it called theta. In the second quad it called 360 minus theta. Theta equal shift cosine half equal 60. So it will be 360 minus 60 equal 300. So the common solution in both cases is 300. Therefore theta equals 300. Okay, the next one. Find the value of each of the following. By looking carefully, I can't evaluate this one because it's very, very long to calculate. Okay, so I will use my mind here. Cosine 20. Cosine 20, okay, here this one equal cosine 180 minus 20. Again, 160 equal 180 minus 20. Okay, cosine 180. Cosine 180 minus 20 equal negative cosine 20, because 180 doesn't change the function, but in the second quad cosine is negative. So this one is negative cosine 20. Okay, so I will cancel this with this, and cosine 40 with cosine 140. Cosine 60 with cosine 120, and so on. So the remainder is cosine 180. Cosine 180 equals negative 1. So the final answer is negative 1. Now let's study the summary of the rule. And this is the end of the video. I hope it was helpful for you. See you in the next video إن شاء الله. السلام عليكم ورحمة الله وبركاته. Mr. Ahmed Mahmoud was with you.